about number 20. And number 20 is y f of x equals tangent to the fourth of x cubed. Got your homework out, you can see that. The first thing that I'm going to do is I'm going to rewrite this. I'm going to rewrite this so it looks like this. Tangent of x cubed 1 to the fourth power. That is the same thing as tangent to the fourth power, but you're going to want to do this. Because this now lends it nicely to chain rule. That's what this one is all about, is chain rule. And there's actually a double chain rule with this one. What's the outside for this one?
For tangent.
Well, then just what's the outside piece?
Just
to the fourth power. Parentheses to the fourth power. My inside is literally what? Tangent. Because it's not a plain old x, I'm not going to put tangent x. I'm going to put tangent parentheses, and then I'm going to have the inside, double inside. What's the inside? Alright. What's the derivative then? The derivative of the outside, 4 parentheses cubed. The derivative of the inside. Go to the tangent.
Secant squared.
Secant squared. Yep. Talk about that in a second. And derivative of x cubed.
3x squared.
What do I do with all these? I'm going to put them together by multiplying. Alright, let's start with this one. What was in this to start with? X cubed. What was in this one to start with? My last step is to do some combinations. I can combine 4 and 3x squared. 12x squared. Tangent x cubed. Quantity cubed. Secant squared x cubed. If you wanted to, you could also write this as 12x squared tangent cubed x cubed secant squared x cubed. I don't care. They do mean the same thing. Alright. So okay with those. Alright, number 8 is what you wanted next, yeah? One more. Number 8. Let's do f of x equals parentheses x squared plus 1 and then equals secant x. There are 2 ways that you can do this. You can recognize that I'm going to be multiplying 2 things together, or you can distribute the secant x and then do it. It actually does not matter which way you do it. You do get out the same answer. So Omar, do you want me to distribute, or do you want me to do it like this? Okay. So if I distribute, I get x squared secant x plus secant x. This is going to use what? Product rule. So, first, x squared, derivative of secant x.
Secant tangent.
Yep. Secant x, tangent x, plus the second, which is secant x, plus 2 times the derivative of x squared. Plus derivative of secant x. Which again was secant x, tangent x. So I literally have, I'm going to clean this up a bit. X squared, secant x, tangent x, plus 2x, secant x, plus secant x, tangent x. Anybody notice anything? I have 2 secant tangent x's, I do, but one of them has x squared attached to it.
No, you can take out a secant.
I can take out a secant x. See if it does anything if I take out a secant x. squared tangent x plus 2x plus tangent x all times secant x. Can I do anything with this inside the parentheses?
No.
No. So guess what? I'm done.
Gotcha.
You could leave it in the blue, because I can't do anything with it. This doesn't help me at all, so I could leave it in the blue. Other questions on your homework? Yes, ma'am. 30 what? 32. Ah. Sine of tangent 3x, right? Yep. That's what this is. It says find me dy dx. So the first thing that I am going to talk about is I am going to insert a set of parentheses, just so you can see a couple things. I'm just going to insert that 3x into a parentheses, because I want to talk about inside and outside functions. And to remind you that if I have a sine, cosine, tangent, secant, or cotangent, I have to have something right after it. Has to be sine of something. So it's sine of x, or sine of pi, or sine of 3 pi over 2, or sine of 3x, or something like that. It's going to be sine of something. If it's not, it's just sin. Okay, so just make sure you recognize the difference. But let's talk about this, because this has some insides and outsides. And I did this so that you would recognize that I am talking about 3x, not just x. What's my outside piece?
Sine.
Sine. What's my inside piece?
Tangent.
What's my other inside piece?
3x.
So let's talk about my derivative of the outside. So the sine is cosine. My derivative of the inside, go to tangent.
Secant squared.
And the derivative of the double inside is just 3. Do you all realize that if you write it like this, and literally underneath, that if you go diagonally, what's inside goes in here? Do you guys recognize that? The reason I do this so you can see it easily. Y prime cosine parentheses times secant squared of parentheses times 3. What was in the what goes in the secant squared?
3x.
What goes in cosine? Tangent of 3x. And I'm just going to clean this up. I'm going to put the 3 in front. I'm actually going to put secant squared 3x up front. And it's cosine of the tangent 3x. Reality is it doesn't matter the order, because it's all multiplication. But I tend to do that, especially if I've got pieces and pieces. Yes, ma'am. Nope. Right. That's what this is right there. This is the derivative of tangent 3x. The derivative of tangent 3x is secant squared 3x times 3. When I do these two pieces. Because this is u, and the derivative of u is 3.
So your chain rule like applies to the first one.
The chain rule is all three of them, but this is reality. This is chain rule also. But I use the u when I write the things down. And actually, let's go back to what Cassie was talking about. So if you look at yesterday's notes, the last class's notes, which you had your videos, right?
Yeah.
All right. How'd the videos go? Okay. Trying, but you got through it, yeah?
Yeah.
And did anybody go back and see him again? Was that helpful? Maybe, kind of. Okay, so